All right. So everyone get started on the review right now. With that, try not to show you my answers. The review should look something like this. We're going to take 3 minutes on the review. We have 2 minutes left on the review. You've got about 50 seconds left. I see a lot of thinking work going into this review. Great start to the day. I see many of us are wrapping up and we're finishing. If you're finished right now, you can check over your work. Make sure that if you need any units, you have correct units. All right, review time is up, scholars. What I'm going to ask you to do is let's lift up those. Let's lift up our papers and show everyone our great math work. So just lift it right up to the camera. Great, Nana. We are wrapping it up. We're finished now. All right, so let's go through the answers. Number 1, the volume of the prism in cubic units is 48 units cubed. How many half-inch cubes can fit inside the prism? 384. And if we actually tried to fit 1/4 unit cubes inside the prism, we'd actually be able to fit 3,072. Just a note on how that works. For number 3, you have to realize that every single one of these can fit, every single dimension can fit 4 cubes inside it. So you have to multiply every dimension by 4. So instead of it being 1, 2, 3, 4, 5, 6, instead of this dimension of length being 6, this new dimension is actually 24. It's going to have 24 little cubes along the length, and it's going to have 8 cubes in depth, and it's going to have 16 cubes in height. So when you multiply 24 times 8 times 16, you will get 3,072. So I'm going to call on a few scholars, so be ready to answer out. In our last lesson, we learned to calculate the volume of rectangular prisms, including ones that had sides which were fractions, like 3.5 or 2 2/3. We used the volume formula. I'm just going to write here, just remind us that the volume formula is V is equal to length times width times height. We're going to continue working today with volume, but on real word problems. So what strategies can we use to understand word problems and to help us solve them? If you want to volunteer, go ahead. Otherwise, I'm just going to pick. I see Naya has raised her hand. Thank you, Naya. I'm unmuting you. Go ahead.
So we can use like many strategies. We can use many strategies like visuals, pictures. We can draw out the problem and then we can see.
Yep, so drawing out the problem so that we can see it, absolutely. What's one other? Let's get one other real quick before we move on. What other strategies do we have to help us understand and also solve problems? Alejandro, I'm gonna go to you. Other than drawing, what can we do?
We can also break it apart and do like the length and the width first, and then you do the height after.
Okay, so Alejandro is describing doing things in steps. So basically do things step by step. Absolutely, Alejandro. And today, the strategies that we are going to practice are going to help you not just with word problems related to volume or of rectangular prisms. They're really problem-solving skills that will help you solve any type of problem. So to start this lesson, what I would like to do is I'd like to show you how I would solve a problem. And I'm going to review these problem-solving strategies. So on your PowerPoint screen, we have a list of all different types of strategies we can use. We can list the information that we read in the problem. We can draw pictures and diagrams. We can turn words into word equations. So we could start off by saying, oh, I drive for 3 miles at 5 miles an hour. So 3 miles times 5 miles an hour. I'm just using words. And then later I'll turn it into math. I'll turn it into a number sentence, which is our next thing that we can write down. We could always guess and check. We can use organizational charts. Make it simple. When you have lots and lots of variables and things that are all on your page, add them together, simplify them so that you don't have a big mess on your paper. Organization becomes very, very important when you solve multi-step problems. And as always, whenever you have if you have a multiple choice question, you could always eliminate answers that you know don't make sense. So looking at this list, what I'm actually going to do, Ms. Silla, can we break them out into 2 rooms? Let's just share from a couple of people in each breakout room. What problem-solving strategy do they feel the most comfortable with, and why is that?
I think that was the.
1 second. 1 second. We got to break. Manage participants.
Just let me know when to start it.
Oh, you can break them out. You can break them out now. Just make it like a 1 minute.
What's popping?
I'm gonna work on the we do together now. I'm gonna read out the we do, and then I'm gonna recruit some of you to help us with our strategy work. The length of a rectangular prism is 3.5 times as long as the width. The height is 1/4 of the width. What is the volume of the prism if it is 3 centimeters wide? Well, I'm going to start off with one thing. Something that many of you have already said is actually like sketching or drawing a diagram. So I'm going to draw a little diagram right over here. I don't know exactly what my dimensions are yet, but I know it's a rectangular prism. And so I'm going to draw myself a rectangular prism, and then maybe I can label that later with more information. So everyone, yes, I see, excellent. I see everyone is following along, drawing a diagram of this, quick sketch of this rectangular prism. I'm going to call on Synovia. Synovia, what is this problem asking us to find?
This problem is asking us to find the volume if the width was a different dimension.
It's asking us to find the volume if the width is a different dimension. Different from what? Let's go ahead and reread this problem. What is the volume of the prism if it is 3 centimeters wide? So they tell us exactly what the dimension is. So not just any old dimension. What is the volume if it's 3 centimeters wide? Anthony, what do we know? What information can we list that we know which is going to be useful to us? You're unmuted.
We know that the perimeter length is like 3.5 times as long as the width, which means that we're gonna probably have to like divide or some sort in order to try to find the length. I mean the width of it.
Okay, so we know that the length, is 3.5 times longer than the width. Great. Silas's hand is raised. Silas, coming over to you. You're unmuted.
I especially disagree, and I think that we're supposed to multiply 3.5 by 3 times the width, because it says 3 times as long as the width. So if we're gonna divide, it's gonna make it smaller.
All right. So let's go ahead and let's go ahead. So our plan here is that we do know that we need to find the volume, right? And we know that our volume is equal to length times width times height. We know volume is equal to length times width times height. So now we have to think, do we know the length? Do we know the width? And do we know the height? We know that the length is 3.5 times longer than the width. Okay, great. But I don't know exactly how long it is, at least not yet. But I'm told that the width is 3 centimeters. So everyone right now, go ahead, and if the length is 3.5 times longer than the width, and the width is 3 centimeters, find how long this length actually is equal to.
Alexa, what is 3.5 times 3?
3.5 times 3 is 10.5.
Anthony needs to get muted.
The answer is 10.5.
Okay. So yeah, 10.5. So 10.5. So our length is actually 10.5. Let's do our height then. Let's go to Quincy. Quincy, are you with us? What is the height now of our rectangular prism?
The height looks like it is 1/4
Height is equal to 1/4 of what though?
of the width,
Okay, and what is the width?
3 centimeters.
And okay, so that should be equal to 3/4 if I'm right. Show me agree or disagree. Did I do my math right? So I think that this means that our height then is going to be 3/4. I'll put it here. And our width is then 3 centimeters. I'm going to clean up my page a little bit. Oh, well, it went straight to, it got rid of my my picture there. But now we know that we can use that volume formula from before. So go ahead and calculate the volume of this rectangular prism now that we know the length is 10.5. We know that the width is 3, and we know that the height is 3/4 of a centimeter. Everyone right now is calculating the volume of the prism. Angelina, we're coming over to you. Let's find her.
The answer is 39.375 centimeters cubed.
39.375. I don't think that doesn't seem right to me. And you know why that doesn't seem right to me, Angelina? Because 3 times 10 is 30, right? 3 times 10.5 is probably like a little bit more than 30, but then we have to multiply it by 3/4. So that's going to make it smaller. Let's go over to Katie. Let's find Katie. Katie.
I got 23.62 centimeters cubed.
So I see Anaya agrees. What else? Let's see what else we got scholars. Naya, thumbs up. So yeah, the correct answer is 23.625 centimeters cubed. Always cubed if it's volume. So in this problem, what strategies did we use? Which of the strategies that we discussed did we use while solving this problem? Let's go to someone I haven't heard from yet today. Josue. I'm unmuting you. Josue, what strategies did we use to solve this problem?
We created a diagram. Sorry, we created a diagram and we created a chart like listing all of our what was the word again? We created a diagram that showed we used a list that shows all our units and what we had to do. And yes, we used a word equation and a regular equation, and we used a diagram.
Esther, thank you, Josue. We can make sure we mute him. Esther, what could potentially make this problem difficult? Where could scholars maybe make mistakes?
Scholars can make mistakes when they're multiplying all the length, the width, and the height, and they could probably make a mistake with their answer.
Say a little bit more about that.
I think they can make a mistake with that because when they're multiplying, they maybe can put the wrong the wrong length, and then they accidentally multiply that with the width and the height, and they could get a wrong answer, which could get them to not answer the question correctly.
Okay, yeah, absolutely. So it's possible that maybe they might just see 3.5, 1/4, and 3, and just multiply them together. And they didn't correctly find the correct length and width and height. What I'd like to do now is move on to the second we do, because I'm committed to getting us some good independent practice time today. So we do number 2. Everyone is turning, I don't know if you need to turn your page, but so you should see this this rectangular prism where there is a base. It says that the base is fixed at 36 centimeters squared. So for varying heights, so like if we increase the height of this rectangular prism, the volume is going to change. So for varying heights, there will be various volumes. Part A is complete the table of values to determine the various heights and volumes. What, Lemuel, I'm unmuting you. What are we trying to solve here? Lemuel, can you hear me?
Trying to solve like a table that has a pattern of what the height of the cubic the volume of the cubic centimeters, and then trying to fill out the chart.
Okay, so we think there's going to be a pattern, and we're going to fill out the chart with volume or height according to what we know here. So in order to find the first volume in cubic centimeters, we're going to use our volume formula. Volume is equal to length. So it's going to be equal to length times width times height. Our length is 12 centimeters. Our width is 3 centimeters. And for the first row here, our height is 1. So we're just going to multiply that by 1. I think everyone should be able to do 12 times 3 pretty quickly. 12 times 3. Put it in your row. Twelve times 3 is 36. And there's another way of also thinking about the volume of this prism. Look at this formula right here, area times height equals volume. Can someone raise their hand and briefly explain to the class how this formula describes volume? How is it that area times height is equal to volume? 4 participants raised their hands. Let's see. Ms. Silla, can you just pick one of them? Because I can't actually see the hand raise icons right now. Oh, I see them now.
Sorry, Silas. Go ahead.
Because the formula works because you know basically multiply that by the volume.
I wasn't able to hear Silas. I'm not sure if anyone was. Give thumbs up if you did hear Silas clearly. Yeah, I wasn't. Okay, so the area is the length times the width. So really, this is really just the same thing as saying length times width times height, because the area is the length times the width. So scholars, go ahead and spend the next, take the next 2 minutes and go ahead and start to fill out the table. In about like 30-second intervals, I'm gonna call out on scholars and we're gonna fill out the table together. All right, Eric, go ahead. Finding Eric. Okay, go ahead, Eric.
Do I just say the whole table?
I think actually I want us to get into IP, so I think that that's okay if you start to go through the whole table, and I'll correct anything. So the first, the row for 3 centimeters in height. Go ahead, Eric. What's the volume? All right, I'm going ahead because we need to move forward in time here. So the volume is 108 cubic centimeters. Let's go to the 4th row. So the 4th row, if the volume is 144 cubic centimeters, what will the height be? I'm looking for hands. I'm looking for someone who I can quickly call on. Lysandra, go ahead.
4.
4 centimeters. And if the volume is 180 cubic centimeters, then the height would be
5.
5. Okay. So scholars, just to remind you of some of the skills that you're going to use while you move into IP, we're gonna skip over the rest of the we do and move into IP. We are going to use these problem-solving strategies: listing information, drawing pictures and diagrams, and writing word equations and number sentences. Make sure that you actually really think about what it is you know and what it is you don't know. Don't just look at numbers and say, oh, I need to multiply them together. Because that is actually one of the main pitfalls that, that we as very eager mathematicians make when we're trying to do our work very quickly. So we have about 8 minutes, I think, left in class, 7 minutes. So go ahead and start working on your independent practice. Logan, how's it going? You working on your IP?
Should I unmute him? I think he was saying something.
Yeah.
You won't let me unmute him. Can you see if you can unmute him? It won't let me unmute.
Okay,
him.
okay. Yeah. I'm trying to unmute you, Logan. Just give me 1 second. I'm clicking, no, I'm pressing the unmute button, but it's not unmuting him.
Logan,
Okay, I'm unmuted.
Okay, there we go. Logan?
Yes.
You were saying something?
Yeah. It's because last week I did everything in the packet because I thought that's what we were supposed to do by ourselves.
So you know what you can do right now is review your answers and check your work.
Okay.
I also did what Logan did because I thought that this was for last week because it said March 16 to March 20. So I thought it was for the week that we weren't here. So I did all the work in this packet, in the map packet, and the TA packet.
In 1 minute, I'm gonna go over the answers to questions 1, question 2, and question 3. I'm just gonna read. I'm gonna read the solutions.
Just check over your work and then see if you can find another strategy to solve the question, okay? Thumbs up if you heard me. All right, great. Okay.
And
Because he said
Eliza, what I would really say as you check over your work is really focus on that strategy work. Make sure you're really investing, that you have the lists, right? That you have the word equations. Okay, so I'm going to read out the answers to questions 1, 2, and 3 right now. Actually, I might find, let's see if I can find a blank screen to even write them down. I'm just going to write them right here. This is IP. So the first expression, to find the volume of the rectangular prism, you could have 15 times 3 times 1 and 1/2. For the second one, you could have 15 times 6 times 1 1/2. And for the third one, you could have 15 times 9 times 1 and 1/2. For number 2, what is the area of the base for all of the rectangular prisms? Well, they all have a base which is 15 inches long and 1 1/2 inches wide, which is equal to 22.5 or 22.5 inches squared. And for number 3, determine the sum of all of the volumes. This is where that strategy work would be really important. So the sum of all the volumes, basically, find volume of each. So my list would look something like that. Find the volume of each, and then add all volumes. And I might throw up here a reminder that volume is equal to length times width times height, which is the same thing as base area times height. You go through and follow the step-by-step process for number 3, you would eventually get to the answer of 405 cubic inches. All right. So in closing, today we did a review of the important strategy work that we need to do in order to solve multi-step problems. They help us break down difficult problems so that we can solve them step by step, and so that we don't make mistakes along the way. What I want everyone to think and write down on your packet, right? What strategies did you use to help you solve the problems today during independent practice? So everyone is writing, what strategies did you use today during your independent practice? This is everybody writes. All right, scholars. So right now it is it's just about time for your break. So remember that homework is homework, and we make sure that you have your homework completed before you meet with your advisors in the morning. It was nice to see you all this morning, and I will see you in your next classes when I see you.
Really quickly before you leave, Bintu, Alejandro, and Brianna,